Significant figures are an important way for us as scientists and chemists to show the amount of confidence we have in a number. Sometimes we call these significant figures, sometimes we call these significant digits. In either case, we're taking the word significant to mean important parts of a measurement, and then figures or digits are going to mean the place values of that measurement. And so important measurements are going to contain all known place values for certain. So on like a graduated cylinder or on a ruler, there's lines. Those lines are the ones we know for sure because there's a line that means that place value. And then we're going to take one estimated place value past the lines on the tool because we can guess how far past a line or are we directly on a line for the length of an item or for the volume of a liquid. And again, this is only for measured values. When we're teaching this, though, sometimes we don't really reflect measured values. We just have numbers and we're saying how many significant figures are in this actual item. So when you're actually looking at the measuring device itself, you can look and see the lines that are on that measuring device. But if you're reading someone else's number, you have to figure out how many significant figures are in that number so that you can do the math that's going to happen down the line for our chemistry problems. So the first rule we're going to look at is this: all non-zeros are going to be considered significant. So I'm just going to refer to them as NZ for non-zeros in the notes here. And what we have here is a 7 and a 2. Both of these fall in the 1 through 9 place value range. So here's a place value, the 7, and here's a place value, the 2, and the 10s and in the 1s. So these two place values are what we would call significant. We would say there's 2 sig figs here. And so this one on the actual device would have been the one we knew for certain. That's the one that has a line. And this one would have been estimated place value. The next one over, we have a 1, an 8, an 8, a 9, a 9. All of those are non-zeros. So we have 1, 2, 3, 4, 5 place values that are important to us. And again, this is known, this is known, this is known, this is known, this is estimated. So for example, on really expensive balances, this last place value is estimated. Here we have 3 digits, all of which are non-zeros. And then finally, the 0.77, the decimal point doesn't do anything here. It just gives us 2 place values that are significant. So rule number 1 is really easy. If it's a non-zero number, a 1 through a 9, it's going to count. The second rule is what we call the sandwich rule, because we have zeros that are sandwiched. So sandwiched zeros. And that means that if it's a 0 that's in between a non-zero, so here's a 2, here's a 7, we have a 0 in between, that 0 is going to count. So that's 3 sig figs. In this case, we have an 8 and we have a 9, so that's a rule number 1. And then we have these zeros that fall between that, which makes it 4 significant figures. So on this first one, we knew the 2, we knew the 0, we're estimating the 7. But that 0 counts because it's sitting between a 2 and it's sitting between a 7, 2 non-zeros. Here we have 1, 2, 3, 4. So we have 4 sig figs. And in this example, you can see that we can have a double layer sandwich or we can have a single layer sandwich, and that the decimal point doesn't do anything to the sandwich itself. Same thing right here, 3 sig figs. Here our 3, our 6, and our 9 are all non-zeros. This 0 sandwiched between a 3, this 0 and a 6, and this 0 is between a 6 and a 9. So that means we have 5 place values that are significant. And here we have our 1 and we have our 8, and all of these zeros are being sandwiched by the 1 and the 8. So 1, 2, 3, 4, 5, 6, 7 significant figures. 7 place values that are important to us. And then if we have scientific notation, we have our 7, we have our 5, and then we can mark that 0. We just cover up the scientific notation. That's not important to us for significant figures. So we have 3 sig figs here. What this means is if you're having trouble figuring out how to write a number, if you write it in scientific, this part, the coefficient in front of your times 10, is the important part. The times 10 isn't important, so that makes it easier. Our third rule, and this is the most difficult rule for students, is this. If you have a 0 that's on the right hand side of a non-zero, So that's the NZ again. And so this condition also needs to be met, and you see a decimal anywhere. Decimal is visible. You can see a dot. The zeros are going to count. So in this case, the first half of the rule, 7, there's a non-zero. This zero is on the right-hand side of it. So that first half of the rule is met, but I don't have the and, so this is only one sig fig. Here I have a 7, and I have a 0 to the right-hand side, so that's meeting the first-hand rule, and I see a dot, so that means I have 2 sig figs right here. Notice it didn't matter where that dot was. So we see that in this example, here's a 7, and here's a 0. That 0 is on the right-hand side, and I see a dot, so it counts. This is a 7, non-zero. On the right-hand side, it's over here compared to the 7, and there's a dot, so it counts. Same thing here. This is 2, 7 with the 0 on the right-hand side with a dot. Again, we don't care about the times 10, so there's 2 sig figs. Here's a different type of example. Here's our non-zero. Here's our 8. Then we have a whole bunch of zeros here. We need to find ones that are on the right. These 3 zeros are on the right, or pardon me, these 2 zeros are on the right, and I see a dot, so these ones count. These 2 zeros are not on the right-hand side of a non-zero, so they don't count. So this is 3 sig figs. Here's my non-zero, so that automatically counts. I have zeros right here, all of which are right of the 8, and I see a dot, so all 3 of these count for a total of 4. Here's our 9, a 1, and a 1. That's rule number 1. Here's our rule number 2, a sandwich 0. And then rule number 3 are these zeros on the right-hand side of a non-zero. Here's 1. Yep, so they're on the right. And I see a dot, so they count. So altogether, we have 6 digits there. And finally, here's my 9. That counts because it's a rule number 1. These zeros are not sandwiched, so that's rule 2. Rule number 3, these zeros are not on the right-hand side. Even though I see a dot, they don't meet the first condition of being on the right-hand side. So this has only one significant figure. Hope that helps you learn these sig figs.